Hello YouTube, my name is Tim Sander and today we have a tortoise and a hare and they want to race each other real bad. So we're going to sit back, drink a cold pint of gnarly barley and place bets, figure out who's going to win. So we have the stats of the giant tortoise here, a max velocity of 0.75 meters per second. And then we have the hare in this corner with a max velocity of 13.42 meters per second. So who do you think is going to win this race? Write it down, and we'll see if you're right when we come back. Okay, so we have established our maximum velocities of both our giant tortoise and our hare. And for the purpose of this problem, we are assuming that as soon as these animals decide to move, they are instantly traveling at that velocity. So our giant tortoise has a plan. He says, I'm starting at the starting point. The second the gun goes off, I'm running as fast as I can, and I'm going to go straight to the finish line, which is 1,000 meters away. The hare, on the other hand, decides the gun goes off. He's going to take a little visit to his buddy's house. So he runs 750 meters at an angle 26 degrees west of south, stops at his buddy's house, stays there for 15 minutes, looks at his nifty GPS watch and says, you know what, I think it's time for me to go. I'm 1,490 meters away from the finish line now. So he takes off running at his maximum velocity at an angle of 30.48 degrees north of east back towards the finish line. So the question is, who crosses it first? Okay, now we're going to go ahead and solve for the time it takes for each animal to cross the finish line. So that'll essentially tell us who won the race. So we'll start with the giant tortoise. The giant tortoise's strategy was to go in a direct line, 1,000 meters. We have the velocity of the tortoise equals the change in position over change in time. We know the velocity and we know the change in position. So we'll go ahead and solve for change of t in that situation, 1,000 meters over 0.75 meters per second. And it took the tortoise 1,333.75 seconds to cross the finish line. Now we'll calculate the time it took for the hare to cross the finish line, since he initially went on his little detour, visited his buddy for 15 minutes, and then finally continued on the 1,490 meters to cross the finish line. So to get the total delta t for the hare, we take the time it took for that first displacement vector, plus the 15 minutes of lag time, plus the time it took to travel that second displacement vector. So we'll take our definition of velocity. Velocity equals change in position over change in time. Plug it in. The velocity of the hare is equal to the change in the position for the first vector over the time that it took for that. And you rewrite that for the change in time for the first vector equals the change in position, which we know, 250 meters, over the velocity of our hare. So you can do the same thing for that second displacement vector here, but change out your values and substitute those into the first formula. So you have delta t for the hare is equal to the magnitude of the first displacement vector plus the magnitude of the second displacement vector, all over the velocity of our hare plus the lag time. So plugging in our values, we have delta t for the hare is equal to 250 meters plus 1,490 meters, all divided by 13.42 meters per second. And then we add in our 15 minutes of lag time, and I multiplied it by 60 seconds over 1 minute to get it in seconds. So we find out that it took the hare 1,029.66 seconds to finish the race. So it was like 300 seconds or so faster than the tortoise, which is about 5 minutes. So it won it by a long shot. And one more interesting thing that you can add is, since our total displacement for the race is the same, 1,000 meters, we can calculate the average velocity that each animal took throughout the race by taking the average. This 1,000 meters is the same, and then the total time it took for each to travel. So